Thousands of miles south of the Lupin mine, high in the Andes, another team of NASA-sponsored researchers is on the road looking for life. They pass through the Atacama Desert, one of the driest places on Earth. But their study site is atop the volcano called Volcano.
The reason we chose this place is very simple. This is probably one of the best analog in the world to Mars 3.5 billion years ago, which means only 1 billion years after the planet was formed.
Natalie Cabral, mountain climber, diver, and one of the Mars rover science team.
The first time I came here, I was stunned because I had the feelings I know the place, and I'd never been here. The overarching goal, of course, is to treat this environment as an analog to ancient Mars. It's also another objective is to understand early life on Earth, because this place has many analogy with early Earth and many microorganisms that are very primitive organisms.
Just as at Shark Bay and in the Pilbara, there are stromatolites, rocks made by microscopic life. At the base of the volcano are 2 lakes. Their shorelines are encrusted with dry minerals, and their waters are extremely salty. Chemical analysis shows these deposits are similar to the sulfate-rich rocks found by NASA's Mars rovers. But here, Natalie uncovers something not seen so far on Mars.
This is life. See? Why is life hiding here? Well, it's hiding probably for the same reason that life would be hiding on Mars. It's because we have lots of UV radiation. And it's very cold and there is a lot of wind, and this wind is desiccating everything. So life is taking cover. We don't know yet if life ever appeared on Mars. But if it did, it's probably very good at hiding because it's not possible for life to stay at the surface.
A few days at base camp allows them to acclimate to the high altitude. But though conditions are extreme, they're linked to the world via the web.
We probably have the highest internet cafe in the world.
Stanford's Greg Kovacs is here to study the humans as well as strange microbes. One of his skills is developing instruments to monitor astronauts in space. Here's Greg testing it aboard NASA's Vomit Comet. This C-pod transmits data about heart rate, blood pressure, and oxygen in the blood. To test how well it works, the explorers put themselves and the instruments through some high-altitude paces.
Nice run.
Thank you. Oh, I didn't run.
Then it's time to climb. They reach the summit of the volcano, almost 6,000 meters. But their astrobiological target is just a little lower. Still, this is the highest lake on Earth. Until Natalie came here in 2002, no one had explored these waters. This year, they bring a radio-controlled boat equipped with GPS and sonar to make a map of the lake bed.
We need to understand where the habitat form, what kind of microorganisms are there. And since it's so close to Mars, try to understand how they adapt to this condition, cold, wind, ice, and especially UV in very shallow environment.
It may look like a toy, but just as on space missions, size and weight dictate what they can carry.
So what we try to do is to be as efficient as possible and to reduce as much as we can the size of our equipment. In one sense, this is very helpful because in terms of technology, that allows us to develop also new things.
Natalie holds the women's world record for the highest altitude free diving, meaning they use no oxygen. These cold waters are a world away from NASA's Jet Propulsion Laboratory in Pasadena, California, where Natalie worked on the Mars Exploration Rover's mission. But there's a direct connection. On landing, the rover named Opportunity rolled into tiny Eagle Crater. Her sensors detected minerals made in salty water, perhaps 3.5 billion years ago, about the time the Pilbara rocks were formed on Earth. In composition, the Mars rocks are similar to the sediments surrounding Laguna Verde in the Andes. If Martian lakes lasted long enough, perhaps life might have begun. But then the Martian climate changed. Lakes dried up. The atmosphere was lost to space. UV rays zapped the surface. Did Martian life fossilize into rock? Or could life, if it ever started, adapt to cold and radiation? Though covered in thick ice most of the year, high salt concentrations keep the bottom waters above freezing. And here, just as in acidic Rio Tinto and the sunless Lupin mine, life finds ways to survive. Analysis of the organisms living in the lake shows they've adapted to the extreme ultraviolet radiation, as well as the cold and salty water.
It's beautiful out there. There is a bunch of red algae, just magnificent. So we're expecting to learn on how life can adapt or develop strategy to defend itself against all these extremes that are very analogous to Mars.
Some of the algae have evolved a red pigment, which acts as a kind of natural sunscreen, protecting their energy-generating chlorophyll. The summit lake is also home to a colony of millions of shrimp-like creatures known as copepods. They also use red pigment to shield themselves from UV radiation.
Most life, especially microbial life, bacteria and stuff like that, that are living hiding and do not need the light of the sun to survive. This is also a very good lesson for us when we're searching for life on other planets. It might be that what we're searching for is not obvious at all, and we'll have to look and look very good.
Natalie believes her research shows that life can adapt to survive multiple extreme conditions. Cold, radiation, high salinity, all operating at once. That makes her somewhat hopeful about finding life on Mars.
But I think that if, and this is a big if life appeared on Mars during that time, in my own opinion, it's still there. Because I have been walking the Earth for long enough now to know that life is stubborn. And whenever and wherever it can hold its ground, it will be there.